Welcome to Module 3, How Humans Hear Amplitude and Frequency. After completing this module, you will be able to identify 5 frequency bands of audio, know the frequency and amplitude range of human hearing, and explain the equal loudness principle. We'll also investigate masking, timbre, and the sound envelope. Module 3 consists of 3 sub-modules. This module, 3A, we will investigate frequency and pitch and the bands of frequency. The next module, 3B, will look at masking, timbre, and the sound envelope. And finally, module 3C will investigate amplitude and its relationship to frequency. So let's get started. Module 3A, Frequency and Pitch. Humans can hear frequencies from 20 Hz to 20,000 Hz. We divide this frequency band into sections which we call octaves. An octave is an interval between any 2 frequencies that have a tonal relationship of 2 to 1. Now what does that mean? With a frequency spectrum of 20 to 20,000 Hz, the first octave for human hearing begins at 20 Hz. We notice that the beginning of the second octave begins at twice that, or 40 Hz. So the beginning of each octave is exactly twice the frequency of the previous octave. And we see that the range of human hearing covers 10 octaves. We'll divide these octaves into 5 groups or bands of frequencies: low bass, upper bass, mid-range, upper mid-range, and treble. Let's see what these 5 bands of frequencies look like graphically. The range of human hearing we see is 20 Hz to 20,000 Hz. The first and second octaves go from 20 to 40 Hz and from 40 to 80 Hz. We call this band the low bass. Now 20 and 40 Hz are a bit difficult to hear on the computer, but 80 Hz sounds like this. Low bass provides us a sense of power and fullness, but too much can sound thick or muddy. Let's listen to an example. This is the sound of a piano recorded naturally. And here's the same recording with too much bass added. The next band of frequencies we'll look at we know as the upper bass. This covers the 2 octaves from 80 to 160 Hz and from 160 to 320 Hz. This is the 3rd and 4th octaves. This is what 80 Hz sounds like. In 160. This band of frequencies, the upper bass, provides a balance with the rest of our frequencies and gives us a foundation on which to build the rest of the musical composition. However, too much upper bass can make things sound a little bit boomy. Here's our original composition again. And this is what it sounds like when we increase the upper bass. However, if we don't have enough upper bass, our audio sounds thin. The next band of frequencies takes up 3 octaves, and we know this as the mid-range frequencies. This includes the 5th, 6th, and 7th octaves from 320 to 640, 640 to 1280, and 1280 to 2560 frequencies. This is the sound of 640, 1280, and 2560. Intense, and that's what this band of frequency provides, is intensity. Too much 6th octave is going to make our sound honky. Let's listen to our reference first. And here it is with an increase in the 6th octave frequencies. Too much of the 7th octave will produce a tinny sound. Overall, too much mid-range becomes annoying and fatiguing. The 4th band of frequencies, what we know as the upper mids, is made up of the 8th octave, from 2560 to 5120, 2560, and 5120. The low part of the 8th octave, 3 to 3.5 kilohertz, improves intelligibility of speech, and the upper part of this octave provides clarity and definition. The upper mids provides what we know as part of the presence range. Too much, however, will sound abrasive, harsh, lispy. Here's our original sound. And the same performance with too much mid-range. Finally, our last band of frequencies is comprised of the 9th and 10th octaves, or the treble frequencies. These contain the least amount of power, but they do give us brilliance and sparkle. Here's 5 kilohertz, and this is what 10 kilohertz sounds like. Too much treble can emphasize noise, however, but too little also makes our sound dull. Well, this wraps it up for human hearing and frequency, but before continuing, please consider, can you describe the 5 bands of frequencies and the effects of each on music? Can you describe the difference between frequency and pitch? And if so, please continue to Module 3B, Masking, Timbre, and the Sound Envelope.